Hello everyone. Today I'm going to explain why drone based quantum networks are becoming important, and quantum networks are growing because they enable ultra secure communication using QKD. QKD means quantum key distribution, but QKD alone can't support advanced applications like distributed computing or a large scale quantum sensing. To support these, we need entanglement based quantum networks, the foundation of the future quantum internet. So the traditional methods like fiber cables and satellites have limitations. So fibers lose signals over long distance and satellites have limited coverage, and drones solve these by being mobile, quickly deployable, and able to create flexible quantum links in hard to reach areas. However, drone based quantum networks face challenges such as maintaining high entanglement fidelity, dealing with atmospheric noise, and managing limited drone energy. To overcome these issues, the FGERd protocol, that is Fidelity Guaranteed Entanglement Routing, helps to keep end-to-end fidelity above the required level, which improves throughput and extends the network lifetime by choosing efficient and energy-aware routes. So the next thing is So the next one is quantum entanglement. The quantum entanglement is a special phenomenon where two particles become so strongly connected that whatever happens to one instantly affects the other, even if they are far apart. This connection is usually represented using Bell states, that is like the symbol that is given here, and the entanglement is the key principle behind quantum communication because it enables extremely secure data sharing and forms the foundation of future quantum networks. In the next slide, I'm going to explain about entanglement swapping. So entanglement swapping is a technique that allows two far away nodes to share the entanglement even if they are not directly connected. For example, if Alice and Bob are distant, an intermediate node like Charlie perform a Bell state measurement, that is a BSM, to create an indirect entangled link between them. So this method helps to extend the range of quantum networks and is crucial for long distance quantum communication. And in the next slide, this is the entanglement purification. When the quantum signals travel over a long distances, they get affected by noise, so which reduces their fidelity or quality. To fix this, entanglement purification is used here. So it works by taking two low quality entangled pairs and combining them to create an one high quality pair. So this process helps to maintain the required end-to-end fidelity for reliable quantum communication and is typically carried out at quantum repeaters. So the formula given here is shows how we calculate the purified fidelity for of two entangled pairs. So that is given as a formula, and these are the original fidelity, basically how clean each entangled pair is, and the output is like this. So the formula compares the chance that both the pairs are correct to the chance that both are wrong. This process helps to boost the overall entanglement quality, and in simple terms, the purification makes the entangled pair more reliable, ensuring strong and end-to-end quantum communication even in noisy environments. And this is the picture where the quantum wireless channel is in this form, and the classical wireless channel, drone quantum node, and ground station is given here. Next slide is about routing entanglement, and in this part we describe the basic components of the drone based quantum networks, uh, and we represent the entire networks as a GDEL. Here, the D stands for set of drones, and E represents the quantum links that connect these drones, and L refers to the capacities of those links, that is basically how much quantum information each link can handle. And each drone is not just a simple flying device, it carries a quantum memory and quantum repeater modules. So these allow the drones to store entangled states and extend the entanglement over long distances by performing repeater operation. And the network works using a combination of quantum communication channel and classical channels. All of these is managed under a software defined networking, that is SDN framework. And SDN framework gives the system a lot of flexibility, meaning meaning that the network can quickly adapt, reconfigure, and maintain the secure communication even when the drones move or the environment get changes. So the next slide, sequential purification will be given. The sequential purification, as entangled states move through the network, noise reduces their fidelity. Each link is treated as a phase damping channel, so purification is performed whenever fidelity drops below a set threshold. So a hope by hope purification approach is used here with up to three attempts per link. So achieving around 99% success, this keeps entanglement strong and reliable across the network. So in the C part, routing metric is given. Because drones have a limited energy and stability, routing is based on end to end fidelity rather than distance. High fidelity paths need fewer purification steps, which leads to the better throughput, lower energy use, and longer network lifetime. Then the routing algorithm selects a path using the minimum link capacity and ensuring the smooth and stable quantum communication. And in ninth, in the D part, FGER protocol process. The FGERD protocol works in four steps. The entanglement distribution between the neighboring drones, and the path selection using a modified Dijkshetra algorithm to choose the most reliable high fidelity route, and sequential purification at each hop to boost the link quality, and throughput update after purification to keep the routing decisions accurate. And this will make routing adaptive, reliable, and energy efficient for drone based quantum networks. And in the E part, complexity analysis is given. FGERD is efficient for small and medium drone networks, and its time complexity is moderate since it combines routing and purification, and it requires manageable memory suitable for drone hardware. And And in the last, there is a simulation result uh, on a 20 drone network, 20-meter range, limited energy, which is compared FGER with the QCPs and QCPs WP. And the key findings are throughput slightly drops, the fidelity demands increase, but FGERD still provides their high fidelity and better stability than the other methods, and it stays energy efficient, keeping more drones active for longer time and with a better link reliability, and it achieves higher throughput, stronger fidelity, and longer network lifetime. So the overall the results show the FGERD is efficient, effective for reliable and drone based quantum communication networks. Thank you.